Okay, so in the previous video, we looked at using PaLM in Vertex AI with both using it as an interface in the cloud and also using it with code to create a chatbot from scratch, etc. In this video, we're going to look at basically combining PaLM with LangChain, how you could use it inside LangChain. And we're going to do the same kind of thing that I've done for some of the other models, where we basically look at doing a conversational bot, doing a kind of retriever bot. And then also in this one, I'm going to look at doing a PAL chain to assess the reasoning of the model as well. Okay, so you're going to have to install these packages here to basically get this going. And it's very important that once you've installed them, you have to restart the notebook if you're using Colab. If you don't do this, you'll basically run into errors later on. Once you've restarted the notebook, you basically go through the authentication dance with Google Cloud, just to basically authenticate as a user so that the notebook can then contact Google Cloud and contact Vertex AI specifically. And then you bring in Vertex AI, put in your project ID and your location here to initialize the project. You can see the version of LangChain I'm using. And then we're going to start off just by using the chat format models. So you can see here that from LangChain, we're bringing in the two different kind of models we can bring in, the chat Vertex AI model and the Vertex AI model. So there are two ways that you can actually use PaLM. There's one using Vertex AI and there's another one using MakerSuite. I'll go through a separate video at some point for MakerSuite in here. But this is using the Google Cloud Platform Vertex AI version of the PaLM models. Once you brought in the chat model, you'll see that it's just like using the Turbo API for OpenAI or Claude 2, where you basically need to bring in the different kinds of chat prompt templates. So we've got a system prompt template, we've got the AI message, we've got human message in here. And then to basically load the models themselves, you'll see here I've basically got this one is just the standard completion model. So this is text bison. And then we've got this one being chat bison here for the chat Vertex model. Both of them are set to same temperature, same top P, same top K for there. All right, so to do a simple message, I just make a human message and pass something in. How do you compare to GPT-4? And then just pass that into the LLM here. So you can see here I'm getting back, I am powered by PaLM, which stands for Pathways Language Model 2, large language model from Google AI. So that's just the standard thing of setting up an LLM and then pinging it. Now we could have used the LLM, the non-chat one, and then just passed in a string into that, and then that will return back. So if we want to do a basic chatbot with some memory and search, this is the same as I've done for a number of the different models. And you'll see that it's very similar. Only thing that we're really changing here is that we're bringing in the chat Vertex AI chat model, and we're going to basically just initialize that just like we did above here. So we've got everything else is going to be the same from when we've done it for OpenAI, when we've done it for Claude. So we're just swapping out the actual model itself here. So we've got our search set up here. And then you can see that because we're using a chat model, when we're going to initialize the agent, we're going to basically initialize the tools, pass in the chat LLM that we've just set up here. And we're going to have a conversational React description agent is the type of the agent that we're doing in here. So remember that basically just means that this name and the description is being passed in, and the model can then just make a decision to basically use these kind of things. So for example, when we run it, hi, I am Sam. Final answer is it just decides to respond. There's no use of search. There's nothing like that. So we just get this, hello, Sam, how can I help? Now I'm using the same questions that I used in the Claude model. So this allows us to compare some of the strengths and weaknesses of both models. The thing that has changed is that day when I did the Claude model, there wasn't a lot of information about Elon Musk's X.AI on the internet. Now I think there's probably a lot more in search. So it's actually returning different data was. Okay, what is Elon Musk's X.AI? You can see here it basically decides to do a search. It passes in Elon Musk's X.AI. We're getting an observation back, which is actually was the search from DuckDuckGo in this case. And then you can see we're getting the finished chain or the final answer back. Elon Musk's X.AI is a new artificial intelligence company founded by Elon Musk. The company's goal is to understand the true nature of the universe. So it's done a pretty good job at finding that information as we go through it. When we ask it who is on the team, we can see that, okay, it probably hasn't done as good a job as before, more because the search results seem to have changed rather than the actual LLM changing anything. So we get back that the team at Elon Musk's X.AI is comprised of engineers from Google, OpenAI, and other top AI companies. What do they plan to do? Again, the search now is delivering different results than what we had last time. So we can see there's some talk about what they're doing and what they announced. In this case, the model's final answer is that Elon Musk's X.AI plans to build a rival to ChatGPT. I don't think that's exactly what they outlined. They were more interesting in doing some other things, but it's certainly an interesting answer. So next up, we're going to look at using the PaLM 2 for information retrieval here. Now, I've basically deleted the files that I've downloaded here. So basically what I did here, if you didn't see the previous video about Claude, is that I scraped a number of different sites and got a number of different articles about the launch of X.AI. And I also basically scraped X.AI itself to get some information for that. There's not a huge amount of documents. There's only 7 text files for doing this. But obviously, just due to copyright reasons, I probably shouldn't share those here. You should just scrape anything that you want and put in here or put in other text documents, etc. You could even change this quite easily to be PDF files. So you can see here that we're going to be bringing in the Chroma database. Looks like just today, Chroma has basically changed their database. So you need to pin it to the previous version, which I've done up above. Otherwise, you will run into errors. So if you're running into errors in some of the older notebooks, that's probably why. We're also going to basically bring in Pydantic, which it's going to make use of. And we're going to just load up those text documents. And you can see there's 7 of them in total. I'm then just basically splitting them. Another thing to point out here is that we're also going to be using the Vertex AI embeddings. So this is from the PaLM to Gecko model. And you can see we're just bringing in LangChain.embeddings. And this is going to let us use their embeddings for doing the vector store, lookup, etc. as we're going through this. So we bring in the documents. There's only 7 of them. We're going to split them up into nice chunks of 1,000 characters each with a 200 overlap in here. Now, this is some sort of boilerplate code taken from Google that just rate limits getting the embeddings so that you're not going to run into errors or something like that. And then also this is where we're using the Pydantic base model for bringing this in. So we basically can embed documents into this and it's going to return back a number of documents. And we can actually set the batch size for the embeddings that we want to do here. So you can see here, the embeddings are going to be our custom Vertex AI embeddings. These are going to work out to be 768 long. And we can basically look at how many of these do we want to do per batch there. Just testing it out, we can have a look at one of them. You can see, sure enough, that we're going to get an embedding like that. It's going to be 768 long. That's what we're going to be using for the embeddings. And if we look at the embeddings themselves, we can see that this is going to be the text embedding Gecko that we're using in here. And it's basically got the settings that we set up before. All right, next up, we're going to basically make the Chroma database. So here we're just passing in these embeddings into the Chroma from documents. So remember, I'm now using the older version of Chroma. I think this is going to change in the future, but it seems to me that it's just come out in the past 24 hours and LangChain itself hasn't updated to the new one. So for now, we're pinning the version of Chroma to the previous version. I'm passing in the vector retriever, put k equals 7 for this as well, so that we're passing in 7 examples for each one. Makes it a fair comparison to what we were doing before with Claude model. And you can see now we've basically just got to set up our LLM. So again, we're using the chat LLM for this, and we're just going to stuff everything in. And we've got our retriever that we've just basically defined up there. And now we've got our QA chain to basically ask the questions. So if we ask, what did Elon announce? Elon announced the formation of X.AI, a new intelligence company. The goal of X.AI is to understand the true nature of the universe. So that's a very good answer. And remember, this is no longer using search on the internet to do it. It's just getting the answer from those 7 docs that I scraped and put in there. So we're doing a vector store lookup, and we're bringing the 7 top results back, and then we're looking at those in here. When we ask who is on the team, remember if we asked this on the internet, it didn't get good results. Here we're getting very good results. Team is led by Elon Musk, CEO of Tesla and SpaceX. Team also includes, and we've got names of many of the people on it. So one that it didn't seem to get right, whereas Claude did, was that what is he going to call his GPT model? So it was alluded that he was going to call it the Truth GPT model. That's not in here. It basically just says he's not announced here, which is technically true because he just alluded to it in the previous one. Who's going to be CEO? And this sort of shines an interesting light on how the PaLM 2 models and the OpenAI models are quite different than the Claude model. So I don't think it specifically says that Elon Musk is going to be the CEO, but it's kind of hinted at a lot. So PaLM 2 basically just makes it a straight up fact. Whereas if you go back to the Claude results for both this one and this one, it tends to hedge a little bit, or it tends to tell you that, okay, while there was no direct answer for this, this is what it was alluding to, or this is what I think the answer probably is. And that's the same for this question here, is where is the company going to be based in here? And the final one, asking about the China and AI, it gives us the information back. It doesn't give us the quote where Claude model was prepared to actually give us a direct quote, which I checked it was exactly in there. It seems that perhaps the PaLM model is less likely to give us quotes. I don't know. This is something you'd want to test out more going through. All right. The last thing that I wanted to look at with PaLM 2 is the whole idea of using PAL chains. So remember, PAL stands for Program Aided Language Models. And so the idea here is that we're going to use the Vertex AI model. We're using just the standard completion model here. So text bison 001. We're setting up the PAL chain from a math prompt. So we can just pass in a question like this. The cafeteria had 23 apples. And this is one of the GSM 8K questions that you've seen me use many times over. And you can see when we give it, it's up to this model to generate code out. Now, we could have actually used the code completion model here too. This is something that you could try out yourself, of testing out the code completion versus just the text completion here. But this text completion model seems to do this quite well. So you can see it generates a function, which then LangChain basically uses the output parser to pass this function and run this in the Python read, evaluate, print loop. And we can see that we get the answer out, which is 9. In this case, the correct answer out. This is one of the things that the open source models are just not good at being able to do, is to be able to generate something out, like a function that works like this, and also has the reasoning correct here. Now, that said, it's not like PaLM gets these all right, but it does get quite a lot of them. So let's look at the next one up. It is able to get this one right. So this one, interesting one of basically comparing prices. It then works out blue ties versus red ties, that he buys 2 times as many red ties as blue ties, which we can see is mentioned up here. And then finally is able to generate the correct answer out. The next one, though, it doesn't get the correct answer out. Here you can see Maggie spent a quarter of her money, while Riza spent 1/3 of her money. They each had $60. So one should have spent $15 and one should have spent $20. How much do they have left? So 15 and 20 is going to be 35. From 120, we should have 85 here. And yet it's doing 25. So the mistake that it's made is, if you look here, is that it hasn't worked out that they each had $60. It's just thinking that, okay, they had $60 to share, and this was the total spend. So sure enough, this would leave $25. This is an interesting case, and it just shows you how language models kind of think as they're going through when they're doing this when they're doing token by token. We want things to be in a good order. So you'll see here that by putting that they each had $60 back here, it's definitely confused it here. It hasn't gotten the right answer. If we take the exact same problem and we write it out, Maggie and Risa each had $60. Maggie spent a quarter of her money while Risa spent one third of her money. How much does two of them left? So I've just changed that one sentence to be like this. And now straight away it can get the right answer. It is something to think about, getting your inputs in a sort of logical format that a large language model can deal with really has a big impact on this. Now you'll find with GPT-4, it probably doesn't need to have that as much. I do think that sort of GPT-4 is a grade above the Bison models, at least. We don't have access to the unicorn models, so we can't evaluate those. But looking at the Bison model, we can certainly see that. Next one up is in November. Toy was $1,000. In December, the price increased by 80%. In January, the price decreased by 50%. What was the price of the toy after the discount? So you can see here, it's done a nice job of toy price, 1,000 times 1.8 for the 80% increase. Then the 50% of the December is going to be the January price. Return that, and it's going to equal $900. It's done a good job there. Repeat words. Now, the words ones, it doesn't seem to do as well for this. So repeat cheese 7 times, every third say whiz. So this one, I guess, depending on how you interpret it, it does cheese, 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 whiz, cheese, 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 whiz, cheese, and then none for that. You could say that's correct, or you could have expected maybe the third one to be whiz instead of cheese there. The next one, though, you can see that it's on track, even with these sorts of things. So this is where the reasoning and sort of logic abilities of PaLM 2 are actually quite strong for this. And we look at the last one. So say the letters of the alphabet in capital letters, only the odd ones. So this should be 1, 3, 5, etc. You can see the result out is we got the opposite. We basically got 2, 4, so we got B, D, F, and those ones. So it's just slightly off in its logic there. It does seem to be getting the right idea, but it certainly hasn't gotten the example for that. Anyway, this is basically how you can use PaLM 2 with LangChain and Vertex AI to be able to handle a variety of different tasks, whether that's just plain chatbots with memory, whether that's using something with a vector store, retrieval or something. And thirdly, whether you wanted to do logic and reasoning tasks with a PaLM there. The PaLM 2 does do quite good at these things. Definitely has a different feel than the OpenAI models, has a different feel than the Claude models as well. So try it out and see what you think. As always, if you've got any questions, please put them in the comments below. If you found this kind of video useful, I'm going to be doing more videos around these topics. Please click like and subscribe. I will talk to you in the next video. Bye for now.